In this video, we're going to create another Fusion 360 PCB library component linked to a manufacturer's CAD file. Hey everyone, thanks for joining. And if you haven't taken a look at the first two videos in this series, I strongly recommend that you take a look at least video 2 to get a basic understanding of creating a library and how to create a device, a symbol, and a footprint. We're going to be using the continuation of the library we created in video 2, so it is important that you at least know how to create your own library, so that way you can understand and follow along with what we're doing. Also note that in the description of this video, we have a couple links. One is going to be a link to DigiKey for a product from Phoenix Contact, and the other link is a direct link to Phoenix Contact's website where we can find the 3D CAD file. So the first thing that I want to do is I want to move over to the DigiKey site and take a look at what we're going to be doing. On the DigiKey site, it's a link for a product that's 1770940. This is a pretty cool connector because it's through hole. There are 2 pins for each location and they're connected internally. And this allows us to take a bare wire and push it into the connector and it'll be locked in place. There are small recesses above each hole that allow us to stick a small screwdriver in there and release the contact. That way we can pull the wire back out of. So if you're a hobbyist and you're looking to make your own circuit boards, this is a great way that you don't have to worry about terminating pins on connectors, because you can just take your wire and you can make sure that it's clean and straight and push it into these connectors and then still get them back out without having a specific crimper or any way that you need to terminate these wires. So this is a pretty cool contact, and I want to make sure that we understand how to create the symbol, how to create the footprint, and how to link it to our manufacturer, the 3D CAD file. So that way we understand the entire process of using this in a PCB design. The first thing that you want to do is you want to make sure that you have the data set. Now, the data set can come from the download from DigiKey, but I've actually found that with this specific part, that the 3D model and the data from the manufacturer, in this case Phoenix Contact, is actually a bit more complete. So you'll notice, for example, in the overview that we have 2.5 millimeter spacing between pins. Now I'm going to be using 2.54. It's the standard 0.1 pitch. And this 2.5 is going to be within the range based on the pin sizes that we're using. You'll notice that they have 0.5 millimeter squared for the wire that's getting pushed in. That's 20 to 26 gauge, I believe. And then you'll notice that there's technical data, accessories, approvals, and then there's a downloads. Now, on the downloads, you can pick everything you need. We're going to want the technical drawing and we're going to want the CAD data. There's other stuff that you can grab from here. And in some cases, you can actually get symbols and layout information from manufacturers. But today we're talking about creating our own symbol, creating our own footprint, and then using the CAD data from the manufacturer. So make sure that you download these two because we are going to be referencing the technical drawing and the CAD data. Back in Fusion 360, once you have the CAD data downloaded, make sure that you upload it into Fusion 360 in your library. It's going to be important later on because we're going to need it so that way we can associate it with our components. What I want to do before we get to that point and needing it for our device and our footprints is I want to double click to open it up. Anytime we import an IGES or a step design into Fusion 360, I always go in first and make sure that I capture design history. This is important because without capturing the design history, we can't really use positioning because Fusion's not going to keep track of the origin of our components. Once we capture that history, these are free to move about and we can capture their position or revert them back. With that done, let's go ahead and save it, and then we can close it because we don't really need it to open at this point. So now that we're going to get started creating another device, I want to begin by starting a new device. We have to determine what we're going to call this. And in my case, I'm going to do PTSM. And this is the designation for this specific connector. And I'm just going to put an _8. Now, the actual part number from Phoenix is much longer than that, but this is going to give me what I need. PTSM underscore 8, meaning it's got 8 pins or 8 positions. I'm going to say OK. And now I've created that new device, but again, we need to make symbols and we need to make footprints. I'm going to start with the symbol, and I'm going to go ahead and call it the same thing, PTSM underscore 8. Once we do this, at this point, we haven't actually created a symbol yet, but once we do this, again, it's important that we note the origin because all of our dimensions are going to be based off of that. I also want to make sure that we take a look at our view info and make sure that everything looks okay in here. We still have the chip resistor information in the bottom left. That'll change as soon as we start modeling stuff. And then on the right-hand side, there's nothing to see yet. All right, so now that we've taken a look and made sure that there was nothing else in here, we want to get started by creating our lines and placing our pins. What I want to do is I'm going to begin by drawing my lines, and why this isn't strictly necessary, it is helpful for me to see the size and the scale that I'm dealing with. The line width is 0.254 by default, and I'm just going to start in the bottom left, and I'm going to work my way around and work back to that point, and then I'm going to hit escape twice. I'm then going to drag a box around this, and instead of this being in the symbols layer, I can put it on another layer if I need to. So again, just like with our footprint that we created, we were able to move it around to different layers as needed. Now, if you don't want this information to be displayed, then don't create it. Now, in most cases, you'll have a reference layer that you can move things to. In this case, because it's our symbol, we want to make sure that we do see it, and it is going to be helpful for us. Now that we have this basic outline, this rectangle created, we need to understand the width of our connector. So if you downloaded the PDF that goes along, then you'll have a chart in the upper right-hand corner of one of the detailed drawings that shows you exactly how wide each connector is based on the number of positions. In our case, for an 8-pin, we have a 20.5 width, and you'll also notice a 17.5 width between all the pins. One thing that you will notice about these connectors is that the pins are offset. So they're going to start offset a distance of 2.35 millimeters from one side, but then they're going to get progressively more and more offset. This becomes a little bit difficult for us because of the numbers. So we want to make sure that we're mindful of this. So what I'm going to do with this line is I want to make sure that I start it at a position that is easy for me to understand. And I'm actually going to stick my first pin at 0, 0. So I want to make sure that this starts at minus 2.35, and that is going to be my X position. And then I'm going to start it at minus 2.8. Now, if you're looking at the detailed drawing, that's going to give you the distance to position 1 from the origin. Then, in terms of its 2, it's going to, again, be at the same height. So the second number is going to still be minus 2.8. But this first number, for how far it goes, this is going to be our overall width, which is going to be 20.5. So this gives us an idea of how big the connector is. For the other lines, we want to make sure that we follow along with the same information. Now, this is the positive value, and this is going to be sort of the width of our connector. This one is going to be 10 millimeters. This is going to be pretty consistent for all of the connectors, depending on this series, if you're using this PTSM series. Now that's 10 millimeters away, and it's going to 7.62. If I just put a 10 in here so we can see where that's going, you'll notice that it's going up in the X direction. So we want to make sure that we understand what these numbers are doing. So you'll notice if we take this first one to 5, it's actually changing the right hand or the rightmost position of this line because of the way that it was drawn. So it's going to be going from 20.5, that's going to be the overall length, and then it's going to be going up to a distance of 10. So that means that this second number is going to be 10, and then the negative value is going to be minus 2.35. That's where the connector starts. Now, once again, we have to be mindful of these numbers. The overall width of our connector is 20.5, but we're not taking into account that 2.35 millimeters. So it is important, once again, that we keep in mind these numbers are based off of this coordinate system. We're not working just in positive space. So we need to take away 2.35 from this number. So that actually means that we're going to be at 18, and then we're going to go to 0.15. So that means that this number here, instead of 20.5, that's going to be 18.15. And this is going to be the outer bounds of our connector. Once again, it's tedious. It is very important though. The symbol is not as important as it is for the footprint, but it is important that we do take the time to get this right. The next thing that I'm going to do is I need to place a pin. Now, the orientation of the pin is going to be important. We want to make sure in our case that we're going to have these pointing down. And I'm going to start, and I'm just going to simply move over and begin placing these until I get to number 8. You'll notice that number 8 slightly overlaps that end. And again, as I mentioned, these connectors are actually, the bodies are offset from the pins. So this is actually how the connector is. We want to place more, and we're going to be placing them sort of behind on this connector. That's how this works. But again, this is the symbol, so it's not critical that they're here, but there is an important reason that we want to do this. So I'm going to flip these ones around, and then I'm going to just begin placing them over here. And once again, I want to go until I get all the way to 8, and then I'm going to say okay. I'll hit escape to make sure I'm not creating any more. And now each of these has a pin 1 through 8, but I'm going to renumber these. And to do that, we need to select them, and then we can just change the number. So this is pin 1, and it's going to be swap level 1. Now, that's going to be important just a little bit. We'll talk about what that means, but right now we're just going to move on. This is going to be pin 2, and I'm going to call this swap level 2. Then we're going to move on to the next one. This is going to be pin 3, and just the same, swap level 3. Now, the reason that we want to do this, the reason that we want to use these swap levels is in some cases, what you end up having is pins that can be swapped. In our case, with these connectors, the pins on the bottom of the board are actually interchangeable. Now, we're going to be connecting them on a circuit board later on, but these pins can be interchanged. So defining that swap level is just another way for us to tell Fusion that these two pins, any of them that have the number 6, can be swapped. Now, it's not something that we're going to do again. We're going to be using both pins together in conjunction, but it is something that it is important to understand what it means, and I thought this was a good example to talk about it. So now that we have pins 1 through 8, we're going to take care of naming the second row. And what I want to do here is I'm actually going to name this 11 because these are connected, swap level 1. And then the next one is going to be 22. So it's just a way to remind myself to document that these pins are connected. So this next one will be 33, and again, swap level 3. Next one will be 34 or 44 and swap level 4. So as we go down the line, it's the same thing we're going to do. It does take a good bit of time to set these up, and this is a fairly basic example. It has a few pins. We could have used an array and generated these automatically and given it some name convention, but practicing the process of creating these manually is important to understand how the software views them and what some of these values are. We can always come back and we can make changes to anything that we've done, even after we've used this in a circuit board. We can come back and decide that we don't want to use swap levels, or we want to change the names or move pins around. Any of that is perfectly fine. But now we have this basic symbol that has pins 1 through 8, and then we've got 11 through 88 over here. We've got the swap levels determined. These are input-output pins. You see that they have the I/O on them. Now you can tell that I/O is something that we can actually tag if they're going to be in or out, normally open, normally closed, power, and so on. We can change that direction. But in our case, this is going to be just vias or holes that are going to be in our board. Now that we have this created, we can go back to our devices. We can go back to PTSM8, and then we can add the part. Now this is going to be our PTSM8. I can just place it in here, and I can hit escape twice, and now we have that inside of here. We're not done. There's still a lot to do, but we're going to save it. And then we're going to move on to creating our footprint. The footprint is going to also be PTSM_8. I'm going to use that same naming convention for the footprint. It's not required, but it helps me when I'm creating these devices, at least at this level, to make sure that I name them all the same. That way it's easier for me to connect the dots. So now that we have that basic information laid out in the symbol, that lets us create our schematic and connect pins where they need to. The point that we're at now for our footprint is what's going to happen when we drag this onto a circuit board. Well, this is where we need to have all those holes positioned perfectly to make sure that we are actually putting them where they need. So I'm going to start this process by using the PTH pad. Now the PTH pad is going to be important because this is going to create a hole, it's going to plate it, and it's going to be what actually gets created on our circuit board. So we're going to be using the round option, and we need to determine what that size is. Now, if you go into the PDF and we take a look at the detailed drawing, you'll notice that this information is not here. It tells us that the pins are a certain depth. It tells us that the rectangular cross section is 0.8 and it's 0.3 wide. So it tells us that it's a 0.8 by 0.3 rectangle, but it doesn't actually give us the size of the hole that it wants to see. It tells us where position 1 is, and then over here it says 1.2 millimeters is the size of that hole. So if we go back and we come into this, we're going to go to a 1.2 millimeter hole. It's not in our list. We'll have to manually enter it. Then the auto portion of the outside diameter can be changed if we have a specific value that we want to use. Now in this case, we know that 1.2 is the ID. So we can use auto, which will generate the thickness of that hole, or we can come in and we can say, well, we want it to be exactly this number. Now in our case, if we decide that we want it to be, let's say 1.77, that's fine. We can always come back and make changes, but in this case, we're going to do 1.2 diameter, 1.778 on the outside, and I'm going to place this at the origin. Then I'm going to start to move over, and you'll notice that we have a pretty fine resolution. It's important that we understand what the grid is. So when we're creating our footprint, we want to go to our grid settings, and we're going to do 2.54 millimeters. That is going to be the spacing between things that we place. I'm going to come back in, do another pad. It's the same size, but now as I move down the line, it's going to put it at exactly the right location. The detailed drawing says 2.5. We're going out an extra decimal place. That's the standard convention for pin spacing, that 0.1 inch or 2.54 millimeters. So we're going to place pin 2, 3, 4, 5, 6, 7, and 8. Now the second row is going to be a bit different because we have a 5 millimeter spacing that we need to hold. If I go here, it's 2.54. If I go here, it's not exactly 5. It's a little bit more than 5. So I'm going to place it and then I'm going to hit escape. So we know that this is 0, 0. If I select this pad, you'll know that it's at position 5.08. Now it might be close enough, but I'm going to put it exactly at 5. Then I'm going to begin creating more paths. Now, again, we can come in and we can do a pattern or an array, but I'm going to manually place the rest of these, and I'm just going to place them again down the line, and then I'm going to say OK. Now that first one is at 5. If I hit escape and I drag a box around all the rest of these, you see that they're at 5.08. No problem, I can move them all at once by just entering that common value. You'll notice that their other position value is not populated because they're all at different locations in the X direction, but they're at the same height at 5 millimeters. So at this point, we've got pin 1 through 8 and then 9 through 16. If we want to change their values, we can make this one 11. We can make this next one 22. We can make the third one 33, just like we did on our symbol. Now this will help us downstream because we do need to connect all of the pins together. So that way, when we go from the schematic to the PCB or the board layout, that it knows exactly where the wires and the traces need to go. So this is, again, an important step. Don't just use these default values if you have something specific you want to use. I'm going to change P1 to just P1. I'm going to change P2 to 2, and so on. Once again, not necessarily required, but it is helpful, especially when you're learning, to make sure that you understand what these numbers are and what they mean and where they connect. So go ahead and renumber all the rest of these, making sure that you follow the same convention that we used when we set up our symbol. Once you have all of these created, we're going to start and we're going to make the box that goes around the outside of this. And again, we're going to represent that based on the information on the detailed drawing provided. So we'll go to Create, we're going to go to Line, and then we're going to begin drawing a box, and then we're going to move it around afterwards. Once we've completed it, we'll hit Escape, and now we can position it. So this left line, right now it's going from minus 2.54. It actually needs to go from minus 2.35. And I'm not going to worry about the 7.62. I'm going to just set that left side for right now. And then the bottom value is going to be minus 2.8. Now, again, this is based on the 0 position, minus 2.8. And then the overall height of that connector is 10.5. So that 10.5 needs to take into account that minus 2.35. So if we do the math here, we're going to be at 8.15, okay? We don't need to worry about the top and the bottom lines. We're just going to take care of these horizontal lines, and then it'll fix all the rest for us. So now the to distance. Now remember that we were dealing with a 20.5 millimeter overall length, but that doesn't take into account the 2.35. So we need to take that out. If we try to do 20.5 and add a minus, you can't do arithmetic in these dialog boxes. We can only manually enter the correct values. So we're going to go ahead and enter 18.15. And then I'm going to go to this one here and do 18.15. Remember that we are going from minus 2.8. And the upper value, remember, it's going to be 10.5. But we have to subtract that 2.8. So we're going to end up at 7.7. Now, thinking about that, I realized that I messed up the number on the first one. It's not going to 8.15, it's going to 7.7 because the bottom row here is offset 2.8, not the 2.35. So now we have this box. This box is representing the size of the connector when it's placed on the circuit board. We have our pin identifications, but if we want to add things like names, that's pin number 1. It's already named. We've adjusted it. That's pin number 2. But we don't have any text associated with those. So if we want to add that value, if we want to put some indicators on our PCB, let's say that we know what pin number 1 is going to be. If maybe it's going to be power in or ground. We can add text values. We can say that we can just say pin number 1. And if we want to rotate this, we can change the orientation. So we'll come into our angle and we'll select 90 degrees and we can just put it here. And now it's going to help us identify the position of pin number 1. So now that we have this information, let's go ahead and navigate back to our devices. We're going to go to our PTSM8. I'll double click on it. And then I'm going to add new from local package. So I've got my PTSM8. I'm going to say OK. It's been added in. We need to map those connectors. We're going to connect, once again, 1 to 1. And then it's got 2 to 2, 3 to 3, 4 to 4, and so on. And then we get to 11. You can see that it's very easy to connect, assuming that we named them all the same. Now everything's connected. We've got all our swap levels. We got all these components together. Make sure that we save. We're not done yet, but we do want to make sure that we save. We're going to go back to our footprint. And now we want to create the 3D representation of this. Now this happens with what's called a package. We're going to create a new package. And when we do this, it's going to bring us in and try to create something from a component generator. Now this is fine if you're creating something based off of a standard. Now you can see here we've got spacers, we've got, if we scroll back up, we've got our chip resistor that we made. And if we select this, we can pick the different sizes for the footprints. Very easy for us to determine what these are. We want a custom. This would have been very easy for us to define our 1206 footprint. I'm going to cancel out of this, and I don't want to add this to the library. So back in my library, this untitled thing, I don't really want to do it. I don't want to save that. There's another way. So when we're in our device, if I right click on it, I can create new 3D model. Now this is different from just creating a new package. The reason that this is different is because when we do this, it's going to allow us to generate this, and it's going to bring all that information that we created, that we set up, into this package 3D generator. And the reason that this is important is because now we can go into our data panel, we can right click on our component and insert it into the current design. We can also drag and drop it in, but it's just, this is the way that we want to make sure we do it. We're going to rotate it 90 degrees that way. We're going to rotate it 90 degrees this way. And we're not going to worry about the alignment just yet. Once it's positioned correctly, I'm going to navigate to my solid tools. I'm going to go to align. And then I'm going to position my component from the center of this first pin to the center position of this. If it rotates, just use the angle option until it gets to the correct orientation. You'll notice that our border, our offset is just a little bit different than theirs, but that's okay. We're going to say capture position, okay. We'll go back to package 3D, and then we'll finish. Yes, we want to finish. Yes, we want to add it to the library. Yes, we want to save it. All of those things. Once we've completed that step, we want to go back to our devices and back to that PTSM8. Right now, it has an error downloading the thumbnail. You just need to give it some time to update. We're going to close our data panel. And now what we have is our symbol that we created that has all 8 pins that we need, and then it's got the duplicate of those pins. We created our footprint, and the footprint has, again, all the pins. And then we brought in our 3D model from our manufacturer, and we use that right-click option on our device to create a new 3D model. Now that is the difference, the distinction is using that create new 3D model enabled us to bring our pin layout, the device footprint, and bring it into our Fusion 360 model. In another lesson, another video, we're going to go over that component generator, and we're going to see how the component generator will actually generate the pads for us and bring them back into our footprint. But for right now, we want to make sure that all this work that we've done is understood and that we save it. So make sure that you do save your library. And just as a quick check, let's go ahead and navigate back into Fusion. Let's create a new electronics design. Let's create a new schematic. And let's bring in that new component that we created. So once again, we're going to go to our lead library. And now we should see our chip resistor and our PTSM8. We're going to say, OK. I'm going to place it near the origin. Say OK, and then I'm going to push it to my PCB. When I push it to the PCB, that is going to be something I can now position on the board. Now, when I position it on my board, I can push it to the 3D model. When I push it to the 3D model, it's going to generate the PCB. It's going to populate it with all the holes, and it's going to put our 3D package on there. So this is the entire process. You'll notice that we've got the holes in the board. We've got the pins that come through. You'll notice that there is a slight deviation, that the pins on the left-hand side are slightly offset. The pin on the right-hand side is centered, and that's because there are some tolerances involved. The CAD model is drawn ideally, but there are some pluses and minuses involved with these values, which is why the vias are oversized. It's plenty of room for the solder to take up. But that is the basic process that we use to create the manufacturer's model. If we hide the package, you can see that it created the holes, they're plated. We've got our white solder mask, we've got the writing on the top, we've got pin 1 location, and we've got our 3D model associated with it. And all that stems from first creating that symbol, which has all of our pins on it, then creating that footprint. The footprint is what's going to pop those holes through the board, and it's going to allow us to reposition it. We can rotate it around, move it, and if we make any changes, we just push that back to the 3D PCB. It's going to regenerate it, it's going to move it to the new location, and it's going to update all of that information. So this process is extremely important that we understand at this basic level before we actually get in and try to create something. So if you had any trouble with anything that we did in the library, from creating the symbol to creating the footprint to importing the 3D model and to aligning it with our footprint, make sure that you review what we've done here. Now, it's not strictly critical that you understand the process of making your own library components, but as I mentioned, in my journey to start learning PCB and creating these, I ran into probably 3 or 4 in my first design that just weren't in the library and I had to make. So understanding this process is extremely helpful, especially when you hit those hurdles. We're not going to be saving this untitled document. We are going to make sure that we are starting from scratch when we create our new components, but it is important that we understand the library aspect of it. We're not going to be using our library components in our new design. So if you weren't able to follow along and you just want to follow along the next video where we start creating, that's perfectly fine. But at least you have this reference to go back to anytime you need to create your own components. Once again, thanks for watching, and I hope that you'll join me in the next one when we start to create our first schematic.